Let's begin. Today's November 23rd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 3, 5, 13, 16, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A takes a look at our middle digit, the square digit, and compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should the value of square be greater than 3? Criteria card B takes a look at our first digit, the triangle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our middle and last digit, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D takes a look at our 3-digit solution and will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? And finally, criteria card E again takes a look at our 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there's a pair, as in the example 131, or alternatively, there are no pairs, but there are a couple of cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing machine does not approve of my choice in triangle. I did choose an odd 3, but since the Turing machine does not agree with it, it's letting us know that triangle should actually be an even digit. So let's go ahead and type that up in our notes in section B. And again, we'll say that triangle is an even digit. And of course, since it is even, we can go ahead and cross out the 3 odds. Okay, so the next thing I think I'd like to test is criteria card D. Okay, so the Turing machine does not approve of my choice. I did pick, or at least my proposal does have 2 odds to a single even. Since the Turing machine does not approve of that, it's actually letting me know that there should be more even than odds. So let's go ahead and type that up in our notes in section D. And we'll say that there should be more even than odds. Well, we've already established that triangle is even, so that guarantees us that either square or circle, one of those has to be even, but there is a potential that all 3 are even. So we are looking at a solution that's either 2 evens and an odd or an all even solution. So let's see. We do have the comparison of square and circle. Just wondering again, are we dealing with 2 evens in square circle or 2 odds? Let's see. Well, let's go ahead and test criteria card C. C. Okay, so it does not approve of my choice of square, or the comparison of square to circle. So notice that my choice of square is 1 and circle is 4. in my case, square is less than circle. So obviously that's incorrect. So either square should be greater than circle or square should be equal to circle. So I'm going to type it up in this order. So let's go ahead and type up in our notes for section C that square should either be equal to or greater than circle. So let's see, can we say anything about that? Well, because I think of the equals, it's hard to actually cross out anything because at this point they all could be equal to each other. We just don't know. But they're either equal or square should be greater. But yeah, we just don't know at this point. Well, let's see. If they are to be equal, that means they would have to be both even. But again, that's still kind of up in the air. Is there anything that could contradict? Oh, well, yeah. So this is the same argument I have. We've already started gameplay, so we already know certain pieces of information. So if square and circle were even, well, then we would be dealing with an all-even solution, therefore making maybe be irrelevant. But again, I don't think we can use that sort of argument. So so at this point, yeah, it's hard to tell what to do at this point. Well, we have concluded this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing that middle digit to the number 3. We still haven't concluded criteria card C, comparing square and circle. And we didn't test criteria card E, letting us know whether do we have a pair or not. So again, let's say, for instance, that one of those values is not, among square and circle, is not even. So we got an odd. It could be that maybe square would easily be a 3, and we do have a pair. So once you establish that, maybe it's easier to see whether it should be, well, I guess at that point it could only be less than if square were even odd. I mean, an odd, irregardless if it's a 3 or not. So that would force us to pick if it could be something like, okay, yeah, square is less than, square is greater than. Sorry, I think I did the wrong indication previously. Square is greater than circle, that it would be something like 3, 2, and then perhaps maybe it's 2, 3, 2. Could it be as simple as that? What else? So if we had a pair, if they're all distinct, let's see, we could have 4, 3, 2 if circle were even. There just seems to be way too many possibilities. And obviously, whatever square is, helps us point out what circle is. But triangle also has to have some kind of play into whether there's a pair or not. Because even though we know it's even, we still have to pinpoint whether it's a 2 or 4. And that's the only thing that really is going to distinguish it. So it would seem that triangle maybe has a little bit less importance because you can always figure out whether there's a pair or not to figure out what that is. So really what it boils down to is criteria cards A and C and seeing what could happen. So, again, I think we need to pinpoint what that square is. So I'm going to say it's 3. And let's see. And of course, if it's odd, then circle must be the even. So I'm going to go with 232. And let's see where that takes us. So just quickly, is that first digit even? It is. Are square and circle either equal or square greater than? Yes. 3 is greater than 2. And yes, there are more even than odds. So let's go with that. Okay, so again, let's go ahead and test criteria card A and see if we can pinpoint what square might be. Okay, so it is not a 3. So it's either less than or greater than 3. Okay, so let's go ahead and type that up in our notes. And we'll state that, yeah, square is either less than or greater than 3. So the only thing we establish is that it is not a 3. Again, it does not mean it's either even or odd. We're not there yet. The only thing we can do is cross out the 3. So let's see. But because we crossed out the 3, I don't know if we can cross out. Can we cross out anything in circle? I guess, let's see, at this point, can we even cross out 5? No. Well, yeah, I think maybe we can cross out 5 because 5 is bigger. We know if circle is 5, then square can't be 5 because we can't have 2 odds. And if circle were 5, then there's nothing square could be that could be bigger. Okay, so that's true. So yeah, we can cross out the 5 in circle. That does sound right. So circle can't be 5 because there's nothing square could be. Obviously it can't be 5, no 2 odds, and there's not a square value that's bigger than 5. Okay, I'm not sure if I could have crossed that out earlier. Could I? Not sure. Yeah. Okay. Well, let's see. What else? Is there anything else? What does that say about? Yeah, I think. I think that's okay. Circle could be 4. Square could be 5. Yeah. Okay. Well, let's go ahead and let's test E. Okay, so we do have a pair of digits. In my proposal, the 2's are paired up, and so, yeah, the Turing Machine confirms that. Okay, so we do have a pair, and it's got to be a pair of evens. So let's go ahead and type that up, and we'll say that the solution has a pair. And of course, we know it's a pair of either 2's or 4's. And unfortunately, the only pair we have is in triangle. Oh no. That's the, well, okay, well, yeah, but as I mentioned, so it's not really triangle that determines it. It's actually going to be square. And that would be criteria card A that we just tested this round. So let's see. How can we figure this out? Oh, by the way, can I now cross out the 1? I think I can also cross out the 1. I didn't realize that. Because if square were 1, it can't be equal, circle can't be equal to it, because that would be 2 odds. And square 1, if square were 1, there's nothing circle could be to be smaller. So yeah, I think I could have crossed out the 1 as well in square. I'm wondering, yeah, that must have been because, well, yeah, maybe I could have done it in the first round. Let's see. Well, no, I couldn't have done it in the first round. It's a result. Let's see. I did B, C, D. No, I think I probably could have done it in the first round. Cross out the 1 and the 5. I'll have to think about that later. Okay, well, it does make sense. So let's see, what else can we do? Okay, so, well, square could still be a 5. Square still could be a 5. Okay. So the question is, wait up. Can we still have an all even solution? Is that possible? If that's the case, then triangle, I think triangle and circle would have to be equal, because if triangle and square are equal, well, it depends on what maybe square could be. It could be something like 2, 2, 1. That makes sense. So let's go. I don't know if there are just too many possibilities or not. I guess if triangle were 2, well, no. Oh, man. Square has to be greater or equal. And again, we have to figure out what triangle is. So it has to be paired up. There's just no way around it. Yeah. Okay. Well, let's see. What could we let's list out some possibilities. So if triangle were 2 and it's going to be paired up, it's got to be if it pairs up a square, it would be 2, 2, 1. Based on the fact that square is either going to be greater than or equal. And that might be the only possibility if triangle and square are paired up with 2's. Yeah. Okay, so what about triangle and circle? So it could be, well, that may not work out. If triangle and circle are paired up with 2's, how would you pick square among 4 and 5? Both of those would be greater than 3. And how would you distinguish? I don't think you can. So I think that's the only one for triangle. Okay. Well, then am I saying that square should be greater than circle if triangle is the one that needs to be paired up? I might be. because otherwise, how do you figure out what triangle is? Okay, well, let's see what the numbers, how they play out. Okay, so I think that is the only triangle 2 value, 2, 2, 1. Because again, you can't have 4. How would you pick between 4 and 5? They're both greater than 3. And both greater than 2. Yeah, okay, so what about 4? So let's pair triangle up with square, and so that would be 4, 4. And then how would you pick among 1, 2, and 3? You already have your majority of pairs, and 4 is all greater than 1, 2, and 3. How would you pick circle then? Well, it looks like 2, 2, 1 might be the only solution. Let's see. Okay, on the rare possibility that it could be that square, well, yeah, the only other possibility that might work would be 4, 2, 2. Yeah, I guess that's the only other number you have to be concerned with. Let's see. 4, 2, 2. Yeah, because you can't have any other paired up values for square and circle. Well, technically, what about 2, 4, 4 then? Yeah, actually, oh, maybe. Yeah, so technically 2, 4, 4 seems to work even. Let's see. 2, 4, 4. So are there any ambiguous solutions here? Well, both 2, 2, 1 and 4, 2, 2 have a square value that's less than 3, but there is a way to distinguish them, and that's that square and circle are either equal or not. Whereas criteria card F, let's see, they are equal, but what distinguishes them is the value of square. Wow. Yeah, I don't think I can cross any of those out. I think they all fall under everything we know so far about A, B, C, and D. And I guess E, technically. Yeah, there's a pair. Yeah, okay. I think we do have to go to a second round. The question is, which pair are we going to pick? For some reason, I see 4, 2, 2 as being really the rarest of possibilities. But, well, actually, 2, 4, 4 isn't that off either. They fall under the same pattern. We're just picking a different even. But to distinguish, it's criteria card A. Well, let's see. Wow, I don't know. I'm really torn here. Okay, let's go with 2, 2, 1. And I'm just not sure. Let's see, criteria card A, yep, it could be. 2 could fall there. Triangle is even, yes. Square, the middle digit is bigger than circle. That's true, and there are more evens and there's a pair. All right, let's try that out. Okay, well, let's see. What should I test? If I test A and it's a check, it could be either of these, forcing me to test criteria card C again. And if I test C, I would have to I think I'm going to have to test both A and C again. Oh, wow. Okay, well, let's go ahead and test Um, which is there a test that would definitively? Yeah, let me go ahead and test C, because that would definitely tell me that 221 is correct. So let's go test C, and I'm hoping that it will fail. It failed. Oh no! Oh no! It did not accept my proposal because I'm still in the third round. Oh, okay. Oh, that's fine. I think that still works out. Is that right? Hold on, hold on. Or maybe had I already done it? No, no, I had two. Yeah, I did A and E. I'm redoing C. Okay, I think that's okay. Oh my gosh, seems like a roller coaster. I just got lost in the details. Um, oh wait. No, so okay, so based on my proposal, that means that square and circle must be equal. Oh, okay, this is just turning out to be a wild of a solve here. Okay, so we have just confirmed that they have to be equal. Yeah, in the first round, square is smaller than circle, that failed, and square being larger than circle also failed. So we are looking at two equal values. So we are looking for an all even solution. So it's either 422 or 244. And yeah, now it is A will determine the solution. And I have to go to a third round. Oh, goodness. Okay. Well, let's say, oh, I don't know. I have no idea. It doesn't matter. Let's see. Is it more likely for square to be 2 or 4? Just based on the fact that there's two possibilities among 4 and 5, I'm just going to say let's pick 2, 4, 4. And that's the only reason. Let's see. Okay, so we are going to test 2, 4, 4, and we're testing that square is larger. Oh God, this is just. Oh no. Okay, so it's not. So it's not true that square should be greater than 3. Oh goodness, golly, this is like a roller coaster. Okay, so in fact, square should be less than 3. Okay, so there are a couple of things I should have done. For criteria card C in the previous round, I should have crossed out what? I guess technically 1, because it cannot be paired up with square, nor 3. Okay, and I guess technically even the 5. So yeah, at least based on all that, it does look like an all even solution. And now criteria card A, that square should be less than 3, means that it cannot be, a square cannot be a 4. And that means that a circle can be 4 because they are equal. And because you have a pair and it's square and circle that are paired up, triangle cannot be a 2. Okay, and yeah, 2, 4, 4 failed. So let's go ahead and cross it out. Oh goodness. All right, so it looks like our solution should be 4, 2, 2. This is wild. Okay, so let's go verify. Yeah, 4, 2, 2 is our solution. 4, 2, 2. Okay, well, thank goodness. How do we do versus a Turing machine? Well, let's go back. So it is a 5 criteria card puzzle, but we actually did 7 tests over 3 rounds. Well, we'll see how we did. Well, let's do this. We did B, C, D in the first round, and then we did A, C, E in the second round. And the only thing that we got right was E, that there should be a pair. Everything else was wrong. Okay, and we of course retested A in the third round. Okay, so let's go ahead and type that up. So B, C, D were all wrong. And then we did AC, and E was correct, and A was still incorrect. Okay, so how do we do? Oh no, we lost by 1 question. Well, I'm not sure where, it did feel like a little comedy of errors, but not sure where the inefficiency, I'm not sure if, obviously, we were forced to test a third time or a second time in the third round. Had we done it in the first round, maybe that would have helped us out. I'm not sure. It's hard to tell. Just in retrospect, criteria cards A and C both have 3 options. So obviously those are going to be a little harder to pinpoint, though. So maybe I should have tested A and C in the first round, or specifically A. And the others were, potentially maybe 50-50s. So should have maybe thought about that earlier. Well, how about you? How did you do? What criteria cards did you pick? And hopefully you did beat the Turing machine. Let us know what your strategy was in the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe to be notified. Well, until next time, have a great one.